Welcome to Quarks and Antiquarks. So, this video is more of a summary compared with the last one. There are 6 types of quark. 3 of them are on your course, the other 3 we're not going to be talking about. So the others include the top, the bottom and the charm. And you can look up the properties of those in your own time if you wish. All quarks have a charge and they are in thirds. So it might be minus a third, positive a third, or in 2/3, as you can see here. The anti-up will have the opposite charge to the up quark. So it will be negative 2/3 of an electron. The anti-down will have positive 1/3 of an electron, and the anti-strange again will have positive 1/3 of an electron. The baryon number, it takes 3 quarks to make a baryon. The antiparticles again have the opposite value, and that's how you're able to combine 2 quarks together with a particle and antiparticle pair to make a meson, which has a baryon number of 0. So for example, if these all have a baryon number of minus a third and you combine an anti-up with a strange, then you will end up with a baryon number of 0, and that's because you have just made a meson. Strangeness, essentially, is it a strange particle or not? So the strangeness for an anti-up is 0, and the same for an anti-down. Notice that this is a negative number for the particle, and the antiparticle, it's a positive number, +1. Okay, so that's baryons. We've talked about charge, we've talked about baryon number, and we've talked about strangeness. You need to know the combinations of quarks to make different types of particle. So let's have a look at those. So the proton is up, up, down. The neutron is up, down, down. You also need to know the antiparticles for these. So the antiproton is going to be anti-up, anti-up, anti-down, which is just the opposite of the particle. And the anti-neutron, again, it's going to be the opposite of the neutron, anti-up, anti-down, anti-down. You need to know some of the mesons as well. So here are the baryons. They've all got 3, and if you calculate the baryon number, you'll see that. They've all got a baryon number of 3. The mesons have a baryon number of 0, and the ones that you need to know about are the pions and the kaons. So there are 3 types of each. There's the positive, the negative, and the neutral for each. Kaons. There we go. So the positive kaon is an up and an anti-down. So notice that that would be +3, plus a third and then minus a third. The minus pion or the negative pion would be anti-up, down. Notice that these are antiparticles of each other. The neutral is an antiparticle of itself. It's either up anti-up or down anti-down. And you'll notice that because these are the particle and its antiparticle, if you combine both of these in a particle, then those are going to annihilate pretty quickly. So this is a very short-lived particle. The plus kaon is an up anti-strange. So this would have a strangeness of +1, and this would be known as a strange particle. Same for the negative kaon, which is the antiparticle for the positive kaon. Notice that the quarks are the anti-versions. And then finally, we've got the neutral, which is its own antiparticle. So that's the pions and the kaons. You should remember that the kaon decays into pions. The kaon decays into pions. This kaon up here decays into the positive and the neutral kaon. The negative kaon decays into the negative pion and a neutral, and the neutral kaon, it decays into lots of different things. There is the positive and the negative. It can decay into two neutrals. It can also decay into a positive and a negative and a neutral, or it can decay into three neutrals. Okay, so that's the kaon. The kaon will decay into pions. It decays into lots of other things as well. There's lots of other pathways for it to decay into, but it does decay into pions, and that's important to know. Another thing that you need to know about is the decay of the neutron. Remember that the proton is the only stable baryon, so the neutron, being a baryon, is going to decay, and it will decay into a proton. So that neutron will decay into a proton, and it will do so via the weak nuclear force, so it will do so using the W- boson. And that W- boson will decay further into the electron and the anti-electron neutrino.